I'm Anil Kumar and we are trying to understand how to sketch graph of trigonometric functions. One of the most critical thing which we need to understand is time period of a trigonometric function. In this video, we are going to concentrate on that. Now you could be sketching the graph from equation. So I'll give you a few equations here. What you need to do is for each equation, figure out what is the time period, right? So let us say we have function f of x equals to uh, sine of x, right? That is the first one. And then let me add some more. Let's say g of x is equals to cos of 2x. I'm keeping things very simple. The idea is not to complicate the matters now, but to understand the concept, right? So let's say h of x is tan of 2x. And let me take some values with half. Let's say q of x is equal to sine of half x. And let me add one more. I'm using different colors so that we can once sketch them, it'll become simpler, right? So let us say p of x is equal to, so let me write some as cos of 3x. So these are very simple functions where I'm not writing any vertical stretches, compressions and all those things, because we know the time period is really dependent on these values. In general, when we have y equals to, let us say, sine of kx, then k actually decides the time period, right? So in general, the time period t will be equals to, when we are working in degrees, 360 degrees divided by k, as you know, right? So for all these functions, what you can do is you can pause the video and then write down their time periods. Correct? So let's write down time periods and let me make a column for time period here, right? So time period for each one of them is what? So for the first one, sine of x, by default, k is 1. So 360 divided by 1 is 360 degrees, right? So that is 360 degrees. Sine, now cos of 2x, k is 2. When you divide 360 by 2, you get 180 degrees. Tan of 2x, that is kind of critical. Now tan is very special. Let me use this blowing to work out on tan. As far as the tan x is concerned, here time period is equals to 180 degrees divided by k, right? Tan repeats after every 180 degrees, not after 360 degrees, correct? So in this case, it is going to be 180 divided by 2, which is 90 degrees. That is, let me put a star here. For sine and cosine, the time periods are 360 degrees. This is for sine, cosine. But for tan, it is 180 degrees. It repeats after every 180. Remember that part, right? Okay. So let me sketch tan graph here. You know, it'll be handy. So basically, tan graph is kind of like this. It has vertical asymptotes where cos x is 0, right? It's kind of like this, where you will find every wave will be, yeah, let me sketch it. Okay, that's okay. So these are vertical asymptotes which are after every pi, right? So in between, it's always rising, kind of like this, right? So that is how the graph is. So this is pi by 2 and this is minus pi by 2. This pattern is being repeated. Do you see that? And therefore from minus pi by 2 to pi by 2, it is interval of pi, or I should write minus 90 degrees to plus 90 degrees, which is interval of 180. So time period for tan is 180, not 360. So make a note of this. Okay. Now let's continue. We have sine of half x. That means 360 divided by half will give us 720 degrees. and then we have cos of 3x. That means 360 divided by 3 will give 120 degrees for us. So that is how we can relate from equation the time period, right? Now another way to look into these graphs is that when we say sine x, then we are saying that the graph is kind of like this. Is that okay? That means one wave which is extended from 0 to 2 pi. That is your wave, where these points are 0 and 360, I should say. Okay. But when we say sine of half x in this particular case, it really means that this wave has been stretched, correct? This wave has been stretched. And what we really get here is a wave which is kind of like this. So that is sine of half x. It really means that in 360, from 0 to 360 degrees, we have half the wave. That is what it means. K is number of waves. So what is K? So we find that K is number of waves in 360 degrees. So if K is 1, in 360 degrees we have one wave. If K is 2, we'll have two waves. For tan it is different, okay, we're talking about sine and cos. For sine, if it is half, we'll have half the wave in 360 degrees, and for cosine, when 3 we say, we'll have 3 different waves in 360 degrees. So for cos of 3x, when I have to sketch it, right, let's say this is 360 degrees for us, then actually speaking, cos will have 1, 2, and 3. So 3 different waves. That is cos of 3x. So that is how you have to understand and visualize these functions, right? Cos of 2x means there will be 2 waves in 360 degrees, right? So basically, here we will have not just one, starting with minimum, right, maximum, right, one wave, and then this. So 2 waves, that is the meaning. So obviously, if you have 2 waves, then the time period for one will be 180 degrees. There are 2 waves in 360 degrees. So the K value actually gives you number of waves and also the time period. So I hope with this video you get fairly good idea about the time periods. For tan, as I was saying, we have a time period of 180. So here if I say 2x, then we'll have 2 tan functions within 180 degrees. That is what we mean here, correct? So in this case, what we will have here is, okay, so let me sketch them. It's good to sketch kind of like this because, okay, where this time period from this place to this place will be 90 when we are talking about tan 2x between one wave. So it really get compressed, so this distance decreases. So these vertical asymptotes will not be at 90 degrees, will be at 45 degrees for tan 2x. Do you understand? So that is how it is going to be, right? So I hope with this you get visual effect of what the equation really relates to. So if I have, let us say, within a period of, let us say, if I have 1, 2, 3, 4 maximums in 360 degrees, then I have 3 waves and the equation will be cos 3x. Do you get the point? So if I have 5 maximum points in 360 degrees, in that case we'll have 4 waves. Do you understand? 4 waves, because 4 waves, this is for cosine function, and the equation will be cos of 4x. So that is another way of looking at it, right? So I hope this concept helps you to understand and correlate time period with equation and the waves, right? So let me give you a question now. That is my function. Let us say 1, 2, 3, 4, 5. I don't know how many. Okay, so what we will do here is, let us say it's a sine function, right? So we have 1 wave, 2 wave, 3 wave, 4 wave, 5 waves, and it is 0 here, and here it is 360 degrees. Can you write down the equation of this sine function, which has a maximum of 1 and minimum of -1? So that is your question to do. Okay, write down your comments and let me know what should be the equation of this sine wave, which has no other translations. The only thing is, it has been compressed horizontally so that we have 5 waves within 0 to 360 degrees. In that case, what should be the equation of the sine wave? That should help you to summarize and get all the things together. I hope that helps. Thank you and all the best.